Hello dear students, today we are starting a new chapter from your half yearly syllabus, that is the periodic table. So here in front of you the periodic table, which is very important, and this thing is there up to whatever the degree you will do in chemistry. Okay, in other subjects also the application of this periodic table is very wide, very vast. Okay, so I hope everybody will learn this chapter very attentively, and in class 10 also same chapter is again it has given, and different group and different periods characteristics is separately given in class 10. So right now here in this class you have the basic things, what is the historical background, and why it's necessary to make a periodic table. Okay, whatever you are seeing in front of you, that is called modern periodic table. Okay, in where you can see there is here this yellow color is periods, and 1 to 6 left to right, these all are called periods. Seventh period is there, and there is 18 series. 18 series means here up to 18 you can see above below. Okay, they are the 18 series, that is the modern periodic table. Okay, so means 18 groups. uh, so now students, what is periodic table, why we will learn that? First thing I am explaining, the thing is that periodic table means in the world all the elements are present. Okay, all the elements means basic unit. Okay, basic structural unit of a compound of any substance is the elemental from its. So that element, whatever the number of element present in the universe, that all element is present in this table. Okay, and these all elements are present accordingly, and their function, and they are present in a tabular form where their function, their group means their all their arrangement is like that way, that their function, their characteristics is relate with one another. Okay, suppose in hydrogen group there also helium, hydrogen helium group, then here also sorry, helium, not helium group, hydrogen group means that is called it has a proper name, you will learn it, that is called alkaline earth metal. Second is alkali metal. Okay, so okay, one is called, first one, that is alkali metal. Okay, alkali metal series. Second is alkaline earth metal, here is the names has given, then according to the color, then there is different series also. The right side, these are non-metal. So all the metals, non-metals, metalloids, everything is present. Okay, every element is present in this table. So here this is called 1 to second group, first group, and first group, this is the previous series, means Mendeleev, according to Mendelev's periodic table, that is 1a, that is 2a, after that 3a, 4a, 5a, 6a here, and that is 0, 7a, then here it is 3b, 4b, 5b. Okay, that all you understand after completion of this chapter. So here just I am first showing you the struck figure, actual long form of periodic table. Okay, so let's move to the chapter. So here you can see reason for classification of elements. Here these are important in exam, so I hope everybody can write the answer also if it will come in the exam, that it help to study the element properly, then it help correlating the property of element. Okay, then third, it help in the defining the relationship of one element with another. Okay, so the relationship of one element with another also explained by using this table. Okay, then in the beginning atoms are made by chemists to classify element on the basis of factors such as density, malleability, ductility. Okay, so this all scientists from very previous, they try to make a table, make a proper arrangement of all the elements. Okay, in this manner. And they use different different variables. Okay, different measuring units to make this table. Like here you can see that dark density, malleability, but but it everything has totally failed, means no comes in a proper relation. Okay, nothing has come in a proper correlating way. Okay, that's why latter, okay, here you can see uh, that, but none these early classification proves satisfactorily. So after that you can see that obviously the scientists were search of characteristics of an element which will never change. Okay, so because these all the characteristics can be changed with the condition and all other, if you give change the parameters, all others, temperature, heat, like this way, so their characteristics also change. But scientists are searching such a characteristics which is never change. Okay, and that William Prout, who discovered the atomic mass of an element, never differ, and that could therefore form a truly scientific basis of satisfactory scheme of classification. Okay, so later when William Prout discover atomic mass, then scientists recognize that we got a they think that we got a characteristics which is not which is fundamental. Okay, it will not change in element to element, it will change in element to element, but it will not change in changing the different conditions. Okay, so by this way, first Doberener, one scientist, German scientist, give a formula which is known as Doberener triad formula, and he just he proposed a table where he shows, I am showing you, that to the atomic mass of middle element is arithmetic mean of both side. Okay, arithmetic mean of both side means other two elements of a triad. Okay, so Doberener provided triad formula because that time there is around 63 element. Okay, less than that also. Now to there is 118 elements in the periodic table, but before that time to there is only 63 element discovered. Okay, not more. So that's why the scientist gives triad formula. Okay, where give just give an example, then you can understand. Suppose we are giving an example of triad. mm, Here you can see, mm, mm, so here you can see a triad like calcium, strontium and barium. Okay, calcium, strontium and barium. So the atomic mass of calcium is 40 and strontium is 88. So arithmetic mean 40 plus 88, sorry, sorry, that is not 88, that is 137 barium. Okay, so if you just take arithmetic mean of 40 plus 137 divided by 2 means 177 divided by 2 means 88.5. So that is the atomic number of atomic mass of strontium, that is 88. So we are getting nearly same atomic mass, so that is a triad. Okay, so by this way lot of triad has given. Okay, by the Doberener. Okay, so that is the actual thing of triad. And here the following examples make this point. Take three elements, here all are metal, each has oxide. Okay, each has valency 2, so their characteristics is quite similar, so they will form a triad. Okay, take three element another. Okay, there is also which is approximately same, like here you can see chlorine, bromine, iodine, same like you can see they are forming a triad. But actually this law is a failure. Why? That is also given. Okay, so what is if the question will come, what is Debrenier triad, you give the definition and one example, and why the discarding reason of discarding. You see, Debrenier failed to arrange all the then known element. Then known means that time 63 element, so he failed to arrange all the elements. Some triad he has provided around I don't know, but some he group, give triad group, but not all. Okay, that is a big failure, and the law did not fully apply even within the same family. Okay, sometime here you can see what is the why it is not applicable. You can see atomic mass of fluorine, bromine, and if you say fluorine, chlorine and bromine, if you take for fluorine, chlorine and bromine, you can see for halogens. Okay, same group means for halogen chlorine, bromine and iodine it is applicable. Okay, it is following. But in case of fluorine, chlorine and bromine, if you take first three, then if you take the arithmetic mean of fluorine and bromine, okay, fluorine 19, bromine 80, you can check that it is coming 49.5, not 35.5. But it should be followed for a same group or same family. Okay, but that is also not applicable over here. So that's why this theory has failed. Next class I will explain Newland law of octaves. Thank you.